All right, guys. So for this video, I'm going to be showing you guys how you can access the Texas Tech High Performance Computing Center, or HPCC. So I'm using the software MobaXTerm because it kind of has a lot of the stuff that you need in one package. It's a really easy download, free download. So I would highly recommend using this if you're on a Windows machine. If you're on a Mac, it's slightly different, but it follows kind of a similar process. So I'm going to be showing you kind of how to set up your session, how to actually connect to the servers, how to request high performance CPUs, since all of this is something that you're going to need in order to run Cadence on HPCC. So I'm kind of starting here just from a home screen. You could definitely start from this command prompt, but I think it's easier to just create a new session. So what we're going to do is we're going to go up here to the top left and just click session here. And it's going to ask us to choose a session type. That's just going to be SSH. And then for the remote host, this is the part that's key. So in the old days, you could actually directly access the partitions or the nodes that you needed. But now what you actually have to do is you have to go first to the login node of HPCC, and then you request the resources that you're going to need from there. So for the remote host, what you're going to put is you're going to put login.hpcc.ttu.edu. Okay, so login.hpcc.ttu.edu. And then if you want it to automatically fill in your username, just so you don't have to type it in every time, you can click specify username, and it's going to be your E-Rater username here. So for example, mine is AA Carmen, but yours could be anything different. So I'll start off not specifying it just so you can see what that process is like, and then we can kind of take a look at some of these settings, okay? Now, under advanced SSH settings, there's nothing we really need to do here, but we are going to go over to bookmark settings here. So for session name, you could just leave it as default, but you could put something like HPCC login node, or just something that helps you to remember that this is how you get to the login node for HPCC. Or you could leave it blank or just default anything you want, okay? Then you're going to keep pretty much everything else the same. You can kind of play around with it if you want. You could create a desktop shortcut, but this is all kind of peripheral stuff that we don't need. So now I'm just going to press OK, and it'll open us up a new window. And since I didn't specify my username, it's going to ask who I want to log in as. And for me, that's AA Carmen. And then it looks like it's already saved my password here, but normally you would be inputting your password here, and that password is going to be your E-Rater password, okay? So you're going to use your E-Rater ID and your E-Rater password, and that's how you're going to log into HPCC. Now we can see it kind of spit out a lot of information. So we're in the Red Raider cluster. So it's going to start off with this Red Raider thing right here, spit out some information that we have. And now we can kind of start playing around with the Linux file system. But one thing that you'll notice is that no matter what you do, there's no way we're going to be able to run Cadence here. And that's because we can only run Cadence off of a high performance CPU. So in order to do that, we have two options. So depending on whether you're using the Quanah or Nocona partitions, these are going to change just a little bit. So in order to actually request high performance CPUs, you're always going to start with the same command, and that is interactive. Okay. So really quick before we do that, a way you can tell you're not on a high performance CPU is that our thing here starts off with login. So whenever it says login, it means you're just on the login node. You haven't requested a CPU. So it's really not good to run stuff on this login node. So it's good to request a CPU first. So to request a CPU, we're going to start off with interactive, and then we can use -C, and -C, whatever number comes after it, is the number of cores that we're going to request. So if we're going to request cores from Quanah, then we need to make sure we are in between 1 and 36, because 36 is the maximum we can request. So if I type in 36, we also have to tell the partition we want these cores to be a part of, so that's going to be -P and then space, and we're going to say Quanah. Okay. Now, once we press enter here, it's going to wait for the resources we need to free up. And then once we see that we have something that says CPU and then a couple of numbers, that's going to mean we're good to go. We've gotten the resources that we need, and we can start doing anything with the Linux file system. Okay, so I'm not going to start going into Linux commands because there's a lot of resources for that. But this is going to be where you actually work to start Cadence. Okay. Now, whenever we're done with these CPUs, it's good to give them back because it just makes everything work a little bit cleaner. And the way that we give them back is we just use the command logout. So if we type logout, it'll say it's relinquishing the job, job has been revoked, and then it gets us right back to this login node here. Now, it's a little different for Nocona. So for Nocona, first thing we'll do is we'll change the partition we're requesting to Nocona. And then for Nocona, we can actually request anywhere from 1 to 128 cores. Now keep in mind that the higher number of cores that you request, the longer it's going to take for your job to be allocated, because if you're asking for more and more resources, it's going to take more time for that to free up. So if I put in something like 128, we can kind of see, we may wait here for a little bit and see if it ever allocates our job, but we can see it's not going very quickly because we're requesting a lot of resources. So if I hit Control C just to cancel that, you can change this slightly, maybe drop it down to something like 32. It may still take some time because the Nocona partition is very, very popular and a lot of people use it. But what we'll see is that eventually it'll work much faster the less number of cores we request. And then if we do something extreme, only request one core, which would not be good for Cadence because it makes everything take a very long time, then we actually get it very, very quickly. Okay, so this is how you're going to actually be requesting these high performance cores. Now, in order to actually run Cadence, what you'll notice is that if you look at your path variable, which describes pretty much all the stuff that you can run, there's nothing in here that resembles Cadence whatsoever. There's this little bit of Cadence here. That's because I have mine kind of defaulted here, but this doesn't always work. So in order to actually get all the Cadence files that you need, what you have to do is you have to use the command module and load. So module load is going to load whatever module it is that you want to run. So in our case, we're going to do Cadence. Okay, so module load Cadence. It's going to take some time to run. And then if we echo our path again, we can see that now we have Spectre, IC618, Assura. We have all this stuff added to our path, which is the stuff we need to run Cadence. Okay, so if we don't have this stuff and we try and run the virtuoso command, it's just never going to work. So now that we have this up and running, what you would want to do is navigate to your Cadence folder, because if you notice here, I don't have anything like cds.lib. I have these log files, but to know when you're in your Cadence folder, you need to see the cds.lib file. And that is in one for me called acgpdk. If I do ls here, what we'll see is that this is where I have an Assura Tech lib, a CDS lib, and these are all the files that Cadence needs to run. Now, once I'm in this Cadence folder, then you can just run the virtuoso, and then this ampersand at the very end just makes it to where we can still access the command line afterward. So if we run virtuoso and, then it's going to take a moment because we're only on one CPU core here, but this is actually going to open up the virtuoso window for us, okay? So if I just hit Control C, we're going to cancel all of this, and then we will eventually log out. And then I'm going to go back to the Quanah node because it may work a little bit faster in this case. So if I do interactive -C, we'll go ahead and do 36, and then -P Quanah. Now, whenever I've logged out and logged back into a different node, I still have to do the same module load Cadence because it's going to pretty much wipe the slate clean whenever we log out like this. So we still have to do module load Cadence, and then we still have to go to the Cadence setup folder that we have, and it's going to depend, you can make it whatever you want, but mine's acgpdk. And then now we can run virtuoso and, okay? And this should hopefully open up a little bit faster. We can see this warning is, let's see, this warning is pretty much telling me that I have a lock file, and that's totally fine. But if we check here, we can see that the CIW window is opening up now, and this is going to pretty much let us run Cadence the way that we need to. So from here, this is where we can start opening the library manager, things like that, in order to actually, excuse me, in order to actually start running and working with Cadence, okay? So this is on Quanah, like I said, but if you're going to do Nocona, it's very similar. You just have to make sure that you're using the proper procedures and protocols to request CPUs and get a CPU off of Nocona. So if you guys have any questions for how this works, please feel free to leave a comment or just shoot me an email. Other than that, thank you guys for watching.